two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speed VA and VB respectively, the time period of rotation is same. Time period of, they mean to say the revolution. Okay, they are moving in circular motion. Time period of revolution of both these particles is same. Then the ratio of angular speed of A to that of B will be. So how do we solve it?
T is equal to 2 pi by omega.
T is equal to 2 pi by omega. Okay. So omega is equal to 2 pi upon T, or T is equal to 2 pi by omega. So if T is equal, can I say omega will be equal?
Yes, sir.
It's inversely proportional, but still there is no other variable. So if T is equal, if time period of rotation or revolution is same, omega will be same.
Yes, sir.
Yes, sir.
Okay, so what is the ratio? 1:1. Okay,
1:1.
1:1 is the answer. Okay, so next question. An electron is moving in a circle of radius 2 meters with speed of 4 meters per second. Find the acceleration of the electron. Tell me. What will be acceleration?
V square by R.
V square by R. Okay, it is centripetal acceleration only, right? It is moving with constant speed in a circle, so there is no tangential acceleration because speed is constant, magnitude of velocity is constant. Okay, so centripetal acceleration only, which is V square by R, which is 4 square divided by 2, because speed is 4, radius is 2. Okay, so 16 divided by 2, answer is 8 meters per
8.
second square. Okay, in the given figure, A is equal to, what is A? This is A. The acceleration is 15 meters per second squared, represents the total acceleration of a particle moving in clockwise direction. It's moving in clockwise direction in a circle of radius r equals to 2.5 meters at a given instant of time. The speed of the particle is. What should we do? Acceleration is given. What is this acceleration? Is it centripetal? Is it tangential? Or is it the total? It's total, right? It's not directed
Yes, sir.
along the radius, so not centripetal, not directed along the tangent, so not tangential. It is total acceleration. Okay, and we just studied how do we find centripetal acceleration if angle between the centripetal acceleration, this is AC, and the total acceleration is theta. So
A cos theta.
it is A cos theta. This is, we are just resolving A bar in two perpendicular components. So AT is equal to A sin theta in magnitude. Okay, magnitude of AT is A sin theta, and magnitude of AC, which we need now, it is A cos theta. And what is theta? 30 degrees.
30 degrees.
A multiplied by cos of 30 degrees. What is cos 30?
Root 3 by 2.
Root 3 by 2. So let's substitute the values. Okay. We are asked with the speed of particle. Okay, we are asked to find the speed of particle. So centripetal acceleration can be written as what? V square by R. It is equal to A times root 3 by 2. So take this R on other side and you will get V square equals to A multiplied by R root 3 by 2. That is A is 15, R is how much? 2.5. Okay, 2.5 multiplied by 1.732 divided by 2. Okay, doing the calculation. So this will be 1 point. If we divide this with this will be 7.5. 7.5 times. Okay, this is the v square, and we want square root of that. So it is 7.5 multiplied by 2.5 multiplied by 1.732. Approximately, can somebody say? Sorry. 7.5 times 2.5 times. Okay, so can I say it is 8 times 4, near about 32 or something? Oh, the options are also close. This is not expected in NEET exam. It is the NEET question. What will be V? This we have to calculate, right? There is no other option. Okay, do you have cell phone? I have cell phone. Okay, square root of 7.5 multiplied by square root of 2.5 multiplied by square root of 1.732. 5.69. So option C is the answer. Okay, so 5.7. Yeah, I said about 32. Yes, of course this will be greater than. Okay, we can do it this way. It will be greater than 25 but less than 36. Right, we can get it that
Yes.
way. Okay, so it is 5.69 is the answer for 5.7. See this next question. The length of seconds hand of a clock is 10 centimeter. The speed of its tip is nearly. Simple, right? Speed is equal to what? V is equal to R times omega. Okay, what is omega? Angular speed of seconds hand. So omega is equal to 2 pi divided by t. Okay, what is the time period of seconds hand in a clock? How many seconds?
60.
Is it 60 seconds? Yes, it is 60 seconds. Seconds hand completes one revolution in 60 seconds. Okay, so this is 10 centimeters. 10 centimeters multiplied by 2 pi divided by 60. Okay, so again we have to do some calculations. So 10 centimeters multiplied by 2 multiplied by 3.14 divided by 60. So near about, can we say this thing and this thing gets cancelled out? 10 divided by 10. So 1 would be the answer. Yes, no? Near about it's 1. Okay, so this is simple question, right?
Yes, sir.
Apart from
Yes,
the
sir.
calculation part. Calculation, okay. And calculation also, this is 2 multiplied by 3.14. Okay, this is close to 6. And options are distinct. Okay, they are well separated. So this will be the answer. 10 divided by 10. This is 6. Okay, 10 6 are 60. So in denominator we have 60, numerator we have 60. So 1 centimeters per second is the answer. Okay, so a particle is moving uniformly in a circular path of radius r. When it moves through an angular displacement theta, then the magnitude of corresponding linear displacement will be. And all the options are in terms of theta by 2. Okay, so let's see this one. So our object moves with an angle of theta. So initially the object is here and it moves through angle theta. Okay, so because all the options are in terms of theta by 2, there will be some relation. Okay, so what will we do? We'll draw angle bisector, right? And we'll join this line. So this is the displacement. How much is displacement? AB is the displacement, this is radius. How much would be this angle or this angle? Theta by 2, right? This is theta by 2, this is theta by 2. So can you say how much would be the displacement in terms of theta by 2? All the options are in terms of theta by 2.
Yes, sir.
Yeah, tell me. It is this length plus this length, right? Okay, so we have named it already. Let's call this point C. Let's call this point C. Okay, this is the point C. Okay, so can I say it is AC plus CB? Displacement is equal to AC plus CB, right? And if you see this triangle, so in this triangle, what is CB? You can write it in terms of this angle. It is opposite side divided by hypotenuse. Okay, so sine of theta by 2 is equal to, okay, if you look in this triangle, it is CB divided by R, and in this triangle it is AC upon R. Okay, it is equal to AC upon R, and therefore AC is equal to R multiplied by sine theta by 2. And also in this triangle, I can say BC or CB is equal to R multiplied by sine of theta by 2. And the total distance from A to B is this distance plus this distance, right? So it is displacement AB is AC plus CB, which is R sine theta by 2 plus R sine theta by 2. So it is 2R times sine of theta by 2, right? So a ball is moving in circular path of radius 5 meters. Tangential acceleration at any instant is 10 meters per second, and net acceleration makes an angle 30 degree with the centripetal acceleration. Then the instantaneous speed is. This is similar to one question that we had seen. Okay, so tangential acceleration is given. What is given? Radius r is equal to 5 meters, at is equal to 10 meters per second square, and the angle between net acceleration and centripetal acceleration is given. So okay, so centripetal acceleration and the net acceleration, this angle is given, this is 30 degrees, right? So this is AC, this is total acceleration A. Okay, so from this we can find out AC.
Tan theta equal to tangential acceleration by centripetal acceleration.
Tan theta equals to, right, so tan theta equals to, yeah, tangential acceleration is given because, okay, so we'll find out tangential acceleration divided by centripetal acceleration. It will be equal to tan of theta. Good, Sanjay. So tan theta, tan of 30 degrees is at divided by centripetal acceleration, and therefore AC equals to AT divided by tan of theta, tan of 30. Okay, and we are asked for the instantaneous speed. So v square upon r is equal to this, AT divided by tan of 30. How much is tan of 30? 1 by
1 upon root 3.
1 upon root 3. So 1 upon root 3. Root 3 goes to numerator. Okay, so take r on the other side. R is 5. So v square is equal to 5 times AT is 10 times root 3. And once again we have to find out v. So this will be v will be equal to what? Square root of 50 root 3. Okay, so directly it is given. No, it's not. Okay, square root of 50 multiplied by 1.73. Okay, I thought this is the answer. Okay, so it will be 7 multiplied by something, 1 point something, 9.3 would be the answer, right?
Yes, sir.
Because others are less than 7. This cannot be the answer. This is v square. This is not v, right? Yes, no?
Yes, sir.
This is 50 approximated to 49. Square root of that is how much? 7. 7 multiplied by square root of this. Okay, this is 1.732. Approximately, okay, 1.732. Whatever it is, its square root will be greater than 1, because square root of 1 is 1. Okay, square root of this thing will be greater than 1. So you have 7 multiplied by square root of this, which is greater than 1. So answer is definitely greater than what? 7. Okay, so this cannot be the answer, this cannot be the answer. It will be 9.3. This is anyway not the answer. This is v square. It's not v. Okay, so answer is this one. Okay, this is clear. See this question. The position vector of a particle is given by this thing. Okay, and tell me the answer. Option, the velocity vector of the particle is parallel to position vector, perpendicular to position vector, directed towards the origin, directed away from the origin. Yes? Okay, this is position vector of a particle performing what? Which kind of motion?
Uniform circular motion.
Uniform circular motion. Okay, and in circular motion, what is direction of velocity? What is direction of velocity? Let's suppose your object is here. What is direction of velocity at this point if it is performing circular motion? Is it along the tangent? Okay, this is the position vector, this is the velocity vector. How much is the angle between them?
90 degrees.
It is 90 degrees, right? The velocity is tangential, position vector is radial. What is angle between radius and tangent? It's 90 degrees. When object moves to this point, okay, the position vector will be this one. The velocity vector will be directed like this, right? So angle will remain 90 degrees. You got this? What is the answer then?
Yes, sir.
Perpendicular to position vector.
Perpendicular to
Perpendicular to
position.
position.
Okay, this is the answer. Very simple. Okay, let's move on to next question. A particle moves so that its position vector is given by r equals to omega t multiplied by x cap. X cap is your I cap, plus sine of omega t multiplied by y cap. where omega is constant. Which of the following is true? Tell me. This is slightly different but similar question. Okay. So velocity and acceleration both are parallel to r. Velocity is perpendicular to r and acceleration is directed towards origin. Velocity is perpendicular to r and acceleration is directed away from the origin. Velocity and acceleration both are perpendicular to r. Which one? Velocity is perpendicular. That you know. Yes, Sanjay?
Option C, sir.
Velocity is perpendicular to r and acceleration is directed away from the origin. Acceleration is directed towards the origin, no? Towards the center of circle. In circular motion, what is direction of acceleration? The centripetal acceleration.
Yes, sir.
Okay, it is along the radius towards the center. So which option?
Option B.
Option B is the
Option
answer.
B, sir.
Okay, is it difficult?
No, sir.
Not at
No,
all.
sir.
Okay, this is from Neet, I guess 2016 or something. Okay. Next question. Again, the radius of circle, the period of revolution and initial position and sense of revolution are indicated in the below figure. Okay, so can you see this figure clearly? Shall I zoom it? Now can you see?
Yes, sir.
Okay, so particle
sir.
starts from here, right? It starts from here. Okay, and it's moving in clockwise sense, not in anti-clockwise sense. So the y projection of radius vector of rotating particle p is, tell me. Okay, you want to see the options? What is radius? 3. So it is r sine or cos. Okay, right? So 4 cannot be the answer. See, the object starts from this point, it moves like this. Okay, clockwise sense. So suppose your object moves here. Okay, this will be your radius vector, right? How much would be this angle? This is theta. Suppose theta will be equal to omega t. We have seen this.
Yes, sir.
Okay.
Yes, sir.
And now I draw a perpendicular from here on y-axis. I want y projection. Okay. So I will draw a perpendicular on y-axis. So what will be this y projection? This y, it will be r cos theta or r sin theta? This is your r. Tell me. R cos theta. Okay, please remember this. If you are going through the angle, it is cos component. If you are going away from the angle, it is sine component. Okay, through the angle, cos component. Away from the angle, sine component. So this is cos component. Okay, so it is y is equal to what? Y is equal to r cos theta, and theta is omega t, right? So now tell me. So its time period is given. Time period is equal to 4 seconds. So how much would be omega? Omega is equal to 2 pi by t, right? So it is 2 pi by 4, right? So it is pi by 2. Okay, so in place of omega you will substitute pi by 2, right? In place of omega you will substitute pi by 2. Okay, so now which is the answer?
Option C.
Option C is the answer. Okay, so this is clear.
Yes,
Yes,
sir.
sir.
Everybody?
Yes, sir.
Okay, good. So okay, so this is also a simple question. Let's see next one. A particle starting from rest moves in a circle of radius r. Okay, it attains a velocity v0 meters per second in nth round. Okay, which round? Nth round. Its angular acceleration will be. So what do we have to use here? Kinematic equation,
A, sir.
right? Which one?
B square equal to U square plus 2AS.
Okay, v square equals to u square plus 2as. We can use that, right? But we are asked about the angular acceleration. Okay, yeah. So we can use v square equals to u square plus 2 times a multiplied by s. Okay, and from there also we can find out, right? So what will be a then? A particle is starting
Option D,
from.
sir.
So you solved? Good. It might be the answer. Let us check. Okay. So it attains velocity v0 in nth round. So s will be equal to what? The distance covered in one round.
N into 2 pi.
Good.
2 pi r.
N into 2 pi r. So distance covered in one round is 2 pi r. So in n rounds it will cover n into 2 pi r. So 2 times a multiplied by n into 2 pi r. And this is tangential acceleration. Okay. So v this is v0 square. And now you can write this tangential acceleration is what? It is r multiplied by alpha. Okay, so it is 2 multiplied by r into alpha multiplied by n into 2 pi r. So this 2 times 2 is 4. So you get alpha equals to, sorry, v0 square divided by 4 pi r square. No, 4, what
4
happened?
pi n r square.
4 pi n r square. Okay, you get v0 square divided by 4 pi n r square. Option C is the answer. Let's move on to the next problem. The next problem is a wheel is rotating at 900 rpm about its axis when the power is cut off. It comes to rest in 1 minute. The angular retardation is. This is very simple, right? So final angular velocity is 0. Initial angular velocity is 900 rpm. You have to convert this to radians per second. So you are given basically with n, okay, number of revolutions. Okay, so this is n is 900 rpm. So convert it to rps. So 900 divided by 60 rps, that is, so 90 by 6, 15, right? Okay, and then it comes to rest in 1 minute. It comes to rest in 1 minute. So time is equal to 60. Okay, so then what is alpha? So omega naught is equal to 2 pi times n, right? So then alpha will be equal to omega t minus omega naught divided by this time. Okay, it comes to rest in 60 seconds. So let's substitute the values. So omega t is 0. It is minus of omega naught is 2 pi multiplied by 15 divided by 6. 60. What's the answer? Pi by 2. Okay, for a particle in uniform circular motion, the acceleration a bar at a point P on circle of radius r is measured from x-axis is, tell me, here theta is measured from x-axis. What will be the answer? Okay, so we have seen this, that the centripetal acceleration, okay, since it is performing uniform circular motion, acceleration will be the centripetal acceleration. Okay, so what is centripetal acceleration? So in terms of particle performing uniform circular motion, acceleration a at point P are not on the circle of radius r. Okay, here theta is measured from x-axis. Theta is measured from x-axis. Okay, so what will be the centripetal acceleration? Can it be this one?
minus omega square r. Yes,
Minus
sir.
omega square r. Okay, we'll write capital R. Okay, multiplied with r cap, right? And r cap is equal to what? So this can be written as minus omega square r or v square divided by r. Okay, so this can be written as v square upon r also. Multiplied with r cap is cos of omega t multiplied with I cap plus sine omega t multiplied with j cap. So centripetal acceleration is this, right? So you get answer. Okay, so in place of omega t, you write theta. That's the angle covered, right? In place of omega t, you can write theta. Yes, no?
Yes, sir.
Okay,
Yes, sir.
this is your circle and this is your particle, which is performing uniform circular motion. Okay, and you want to measure its acceleration from the x-axis. You want to measure its acceleration. Okay, and this theta is the angle with respect to x-axis. So this theta will be equal to omega t. So this is its position vector. You can resolve it in two components, one along x-axis, one along y-axis. So this will be what? R cos theta. This will be r sin theta. We have seen this. Okay, so this is equal to what? So it is r cos theta. R bar can be written as r cos theta multiplied with I cap plus r sin theta multiplied with j cap. Okay, so so acceleration is what? It is minus of omega square multiplied with r bar. R bar is this, and you can take that r common, and you can write omega square r as v square upon r. So it will be equal to minus of v square upon r multiplied with this thing, cos theta into I cap plus sin theta into j cap. Okay, so this is the answer. Option C is the answer. Right, this is simple. Next question. A particle moves along a circle of radius, this is the radius, with constant tangential acceleration. If if the velocity of particle, they are saying. Okay, I guess this is if is 80 meters per second at the end of second revolution. Okay, after motion has begun, tangential acceleration is. So this is simple, right? Might be calculation heavy. Let's see. So which formula will you use? You are given with r, radius is given, it is 20 by pi meters. The initial velocity is given, it's 0 meters per second, right? Or let's call it u only. Okay, and v is given, it is 80 meters per second at the end of second revolution. That means which another thing is given? 2 revolutions. That means total distance covered is given, s is given, right? S is equal to 2 multiplied by 2 pi r. Distance covered in one revolution is 2 pi r. Distance covered in two revolutions, 2 times 2 pi r, right? So which formula will you use? Okay, you have initial velocity, you have final velocity, you have displacement, okay, and you want to find out the acceleration. So you will use v square equals to u square plus 2 times a multiplied by s. So this is 0, okay, u square. So u is what? 80. So let's keep it as it is, u square plus 2as. Okay, so you can say minus 2as is equal to u square, and therefore s is equal to u. You want what? A. So a is equal to minus of u square divided by 2 times s. It is 80 square divided by 2 times. How much is s? S is this thing, 2 multiplied by 2 pi r. Okay, so 2 multiplied by 2 pi r. Okay, so what would be the answer? You want tangential acceleration, right? And radius is given. Okay, so radius is how much? It is 20 by pi. So let's substitute that. So it is minus 80 square, and you can cancel out that with this. Okay, so 80 square divided by 4. So it will be 20 square multiplied with 4. Okay, no, 40 square multiplied with 4, and this 4 will get cancelled. Okay, so minus 40 square upon, you have 2 pi multiplied with radius is 20 by pi, right? So this pi and pi gets cancelled. So in denominator you have 40, numerator you have 40 square. So answer will be 40. So minus 40 meters per second square will be the answer. Okay. So this is simple, right?
Sir, initial velocity is 0, sir, for substituting.
Oh, initial velocity, particle moves along circle of a radius, this thing, if velocity of particle is 80 meters per second. Initial is 80. Initial is 80. So here I did a mistake in writing. Okay. Final is 0. Velocity of particle is 80 meters per second. No. Okay. Here it's correct. Here it is wrong. It is accelerating, not decelerating. Okay. So there is a negative sign. Okay. So this will be 0. And this is 80. 80 square. Sorry. Okay. This is v square. So this will be v square. There is a difference of negative sign only. Okay, so here also it will be v square, right? There will be difference of negative sign only, so it will be positive 40 meters per second square. Next question. A particle moves such that its position vector r at time t is again the same thing. Okay, where omega is constant and t is time. In which of the following statements is true for velocity v bar and acceleration a bar of the particle? So see, this is from JE, this is not from Neet. Okay, but it is similar question, or is it the same question? Tell me the answer.
Yes, sir.
What is the answer?
Option D, sir.
Option D. V is perpendicular to r bar and a bar is directed towards the origin. Right. This is the answer. All right. So let us solve this. So particle is moving along circular path with constant speed 10 meters per second. What is the magnitude of change in velocity of particle when it moves through an angle of 60 degrees? So let's suppose initially your particle is here. Okay, initially the particle is here. So its velocity will be in this direction, suppose. Okay, and then, I'm sorry, this direction. Okay, then it moves through an angle of 60 degrees. So it moves here. Okay, angle of 60 degrees, right? So this is 60 degrees. And now the velocity is directed in this direction, tangential. Okay, this angle is 60 degrees. This angle is 60 degrees. And now you are asked to find the change in velocity. What do you have to do? You have to subtract this initial velocity, you can call it Vi or V0, from Vt. Okay, so how to do that? Take this vector, put it over here. Okay, put it over here. Okay. Sorry. This is your V0 and you want to subtract it. This is V0 bar. Okay. So how much is this angle? This is 60 degrees. Because angle between radius is 60, it moves through 60 degrees. So this angle will be 60. So how can you subtract this? You can draw minus V0. Okay. So this is Vt, velocity at time t, minus V0. How much would be angle between this thing, this V, and minus V0? If this is 60 degrees, how much would be this angle? 120 degrees.
120.
Right? So now you want to add this vector and this vector and find out the resultant. Okay. So what is delta V bar? The change in velocity. Okay. How much is delta V bar? It is V bar minus V0 bar. Right? It is V bar plus minus V0 bar. Okay. So this vector plus this vector. Okay. So how can you find out the magnitude? You have parallelogram law. You have parallelogram law, right? So delta V equals to square root of, the speed remains constant, or let's write it, V square. Okay, V square plus V0 square plus 2 times V into V0 multiplied by cos of the angle 120 degrees. Cos of 120 degrees. Okay, right? And the speed is same, right? Speed is constant. That means the magnitude of V and magnitude of V0 is same. So see, this will be, I can say this is equal to V only. Okay, so it is 2V square plus, what will be cos of 120 degrees? What is
1 by 2.
1 by 2 or minus 1 by 2?
Minus 1 by 2.
Minus 1 by 2.
Minus 1 by 2. Okay. So it's minus 1 by 2 minus 1 by 2 multiplied by 2V square. So this is just square root of V square, because this will be what? Minus V square. So 2V square minus V square is V square, and you have square root of that. So it's equal to V, right? The magnitude of speed. How much is that? It is 10 meters per second. Okay.
Yes, sir.
Yes, sir.
So let's see this next question. Car is traveling with linear velocity v on a circular road of radius r. If its speed is increasing at rate of a meters per second squared, then the net acceleration will be a means. Tell me. Speed is increasing at rate of a meters per second squared. So which acceleration is this? Which is a? Is it tangential? Is it centripetal? Is it total? Okay, so speed is magnitude of velocity. You know this?
Yes, sir.
Okay, and it is increasing at the rate of a meters per second squared. That means magnitude of velocity increasing is increasing at the rate of a meters per second squared. So which acceleration changes the magnitude of velocity? Tangential or centripetal? Centripetal acceleration changes which thing? Centripetal is due to change in direction of velocity, right?
Yes, sir.
Yeah. So which acceleration is this?
Tangential acceleration.
This is tangential, right? Okay. This is changing magnitude of velocity, no? So this is tangential acceleration. Okay. So A is tangential acceleration. Okay. And now, what is net acceleration? We know what is net acceleration. The square root of AC square plus AT square. So AT square is given to be equal to A. What is AC? V square upon R. So it is V square upon R square plus A square. This is the net acceleration, magnitude of net acceleration. So answer is option C. Simple?
Yes,
Yes,
sir.
sir.